is Chris Johnson-Beidler, and I'm going to give you a talk today I've given a couple times before on Amazon's AWS Simple Workflow. So, first, who is this guy? I've talked to this group before, so I'll keep it kind of short. I've been working in the software industry for about 17 years, most of that time doing Java. Most of the last 10 years has been back-end data processing stuff. And the place that I'm working right now, I've been for almost 2 years. I use Amazon's Simple Workflow framework in Anger every day. It's a document processing workflow engine. It processes about 2,000 documents a day right now, which is just a tiny, tiny sliver of what the company I work for does each day. I work for a company called SPS Commerce. They do EDI, document routing and translation between retailers and vendors and that sort of stuff. Over Cyber Week last year, we did right around 2 million documents a day. And the workflow engine that I'm working on building now will be doing most of that, if not all of it, by Cyber Week next year, using the Flow framework that I'm about to show you. So, the one slide summary. What is AWS Simple Workflow? It's a task coordination framework. It's decentralized, and AWS takes care of all of the stuff that if you were to build your own from scratch and run Jepsen against it, Jepsen would probably carpet you about things like coordination, state management, failure modes, and AWS provides all of that for you. So you build out a description of the workflow that you want in one of two ways that I'll go into later in the talk. And you parcel it out into units of work. Those units of work can be done anywhere. They can be done on premise, they can be done in a Lambda function or something running EC2, they can be done on an iPhone somewhere. Anything that can pull an HTTP endpoint can participate in your simple workflow execution. It can pull a task list, which I'll talk about in a second, to get a unit of work, complete that unit of work, and give the result back. And AWS behind the scenes takes care of stitching together all of those execution results into a coordinated, authoritative history of all the stuff that you've asked things to do that you can then use in your decider logic. So these are terms that get bandied about when I'm describing how the different pieces go together. The decider is the code that schedules the activities to do the work and contains the business logic. Generally, code in a decider is stateless and is just like a set of rules for coordinating different, so for example, you might need to know if you have enough inventory to fulfill an order. The business logic for deciding what to do in that case would live in a decider. The thing that actually goes out and talks to a data store to figure out how much inventory you have and returns that number to you would be in an activity somewhere. Execution is all of the activities that one of your deciders needs to run to carry a piece of business logic through to its completion. So maybe you need to find out if you have enough inventory, order some more inventory, and send an email to the customer saying that the thing will be late because you're out of stuff. So that's 3 activities that are coordinated together by a decider into one workflow execution, and that history of things that happened and decisions that were made is something that you can have set a retention window for. So you have that execution, that's the thing that happened with this workflow event, and it's a discrete unit of stuff that lives in simple workflow history. So the way that all these things are coordinated by simple workflow is using the concept of domains and task lists. A domain is a set of task lists and activity and workflow types, which are versioned, that all are allowed to work together. And a task list is something that one of these things can pull to ask for either more decisions to make or more work to do. And it's generally a good idea to break things out. You don't want all of your stuff listening to one task list, because then all of your different types of code need to do discrimination on what events they get, right? Like if your decider is also listening to the same task list as your email sender, then both your email sender activity and your decider have to have something in them that says, is this event that I got a request to make a decision or a request to send an email? But if you have a task list for each kind of thing, then an event type for each piece of work that comes in, that code becomes much cleaner. An important note: if you use AWS in a serious business kind of way, domains do not cross domains, or do not cross regions. So generally you might have a domain for dev, one for staging, one for production, but if you also need to be multi-region capable, you need to have stuff in US East and US West in case US East falls into the sea. You have to replicate your domain setups across both those regions and then have something to fail them over. Like a Kinesis stream replication to move incoming messages across or something like that. So I would love to show you the workflow engine that I work on at work, but I can't because I don't own it, and my boss doesn't want me to put it on YouTube. So I did the next best thing. I made up a bunch of fictional people and put them in a really crappy situation, and we're going to see if we can't save them by using Amazon Simple Workflow. So meet Wichco. Wichco is a reasonably successful small business. Their IT infrastructure is 100% on-premise. All of the business logic for the work that they do, which is building bespoke widgets on demand in response to incoming emails or website hits, is in one big monolithic app. Their database is one big monolithic database. We can pretend this is like, I don't know, an iSeries from 2004, like something that's really, really not just going to be forkliftable up into the cloud, right? And really isn't multi-tenant, can't be replicated easily. And they're starting to run into problems with scale. They're starting to have orders be late because it's taking so long for their on-premise solution to chunk through the volume of data that they're getting, and it's causing problems. They don't want to lose market share because people get sick of their orders being dropped on the floor. So we're going to see if we can help them out with some Amazon AWS goodness. This is their current business process flow. And it's not that bad. I'll walk you through it. It's not that bad. So the order comes in, and an order is a list of widget types that the person wants in quantities. So first, we check to see if we know about all the widgets they're asking for. If we don't, we tell the customer, I don't know what this is. Try something else. If we do know what it is, then we check to see if we have, we get the bill of materials, and we check to see if we have enough stuff. If we do have enough stuff, then we submit a job to the shop floor to build it and schedule a shipment, because we know how long the shop floor takes to make the widgets. If we don't have enough inventory, second red arrow going down, we order more parts, we tell the customer the stuff's going to be late, we schedule the job, and then when the materials are available and part counts get updated from our vendors shipping stuff to us, that job gets submitted to the shop floor. And this shipment is scheduled because once the shop floor has the parts, we know how long it takes. So all of the diamonds in this diagram are decision points, and all the squares are pieces of work to be done. So we can divide that up then. We have things to put into a decider and a bunch of activities. So this is kind of how that might work out in practice. You might break out your activities by type of thing that you're doing. You're talking to a data store, you're sending stuff to a supplier, so that might have your SOAP or EDI, or this supplier wants purchase orders FTP to this place so that we do that. So you break out these things into what kinds of activities they are. We probably only need one decider for this workflow. It's pretty simple. And then these are some of the things that we might have building this out. We might have a workflow starter that's just a Lambda function. All its job is to send the message to Simple Workflow that starts a workflow in process, causes a decision to be scheduled for whoever's pulling for decision tasks to pick up. And the activity workers and decider might live in EC2. Activity workers could live in Lambda, but I don't want to write SOAP code and try to troubleshoot a Lambda function. So we're going to say that we're just going to take as much of this logic as we can and forklift it up into EC2 workers. And we might store our parts and vendor information in our ES instance. So an incoming order might look like this. You have a REST endpoint somewhere backed by API Gateway, and what's backing that is a Lambda function that builds an input object that our decider expects to get with data about what to do, or what we're asking it to do. puts that into a JSON string and submits it as the input data of a workflow request. Inventory management is the situation where I talked about, where we have to both order more stuff and tell the customer that things are going to be late. So as a result of a decision task falling into a certain part of the logic, we might schedule 2 new activity tasks. You ask the simple workflow service to schedule 2 tasks that you could wait for them both to complete if you need to. And this is an interesting feature of the way that activities are built. So if you have to schedule an activity, you might need to wait for some situation that you want to have manually completed. You might be sending something out to Mechanical Turk or sending an email to someone that has to, something needs to be approved because the purchase amount is more than $10,000 or whatever. You can have a workflow put itself into a state where it's running and it has published a token that allows you to refer back to it using the SDK. And you can set an activity timeout on that that's long. One of ours at SPS Commerce is 2 weeks. And that workflow will just stay running in the simple workflow service until you either resume it or cancel it using that token and an SDK call. So you could, for example, build something on an iPhone or a tablet kind of device in the loading dock at Wichco that when inventory comes in, you scan it in, it puts it into the inventory system, and if that fulfills any waiting orders, grabs their token and starts that workflow to submit the job in the shop floor. So let's take a look at some of this stuff and see how it works. This is the simple workflow service dashboard that you get in AWS when you log in. You know, let me ask really quick, how many people here have worked with AWS services before? Oh, good. That's not as bad as I was fearing it would. So this just lives in, you know, like, come on, there we go. You know, like you log into your console, you get all of your stuff, right? So you have EC2. I have one running instance with stuff on it, and then this is my daughter's Minecraft server. I have an RDS instance that's just storing some simple inventory database stuff. Although actually right now, because I botched a migration, it's holding the schema but not the data. So I can show you a failing workflow but not a successful one because it doesn't know about any widgets. I ask it, do you know about this widget name? No, I don't know about any. So if I wanted to start a new workflow execution from the console, this is what it would look like. Oh, here, first I will show you. So in my domain, I only have the one. I have one workflow type registered, version 0.1.0, because it's the future. Nothing ever gets to 1.0, right? And I have one activity implemented right now, or registered right now, validate widgets by name. And it's going to, and you'll see it's listening to a task list called data store task list because it's doing things with the data store. The workflow is listening to Wichco decider task list. So these are basically queues that decision and activity events get put onto by simple workflow, but you don't have to know anything about them. So you don't have to deal with message coordination, failover, retention, but you also don't get to know anything about them. They're just a name. And they don't have to even necessarily be configured beforehand. You can, when you kick off an activity, say, I want this activity to be listening to this task list. And if there's a special set of activity workers running that are listening to that task list, that one activity will go to them, and the rest of the activities for that defined activity type will go to the default ones. So I was going to show you what it looks like to start a failing workflow. Now in here is where, so the input, the data that can travel along with any one of these events is a string. So the really common thing to do is to have business object that encapsulates the message you want to send, and just serialize and deserialize to and from JSON. And I happen to have, if I can find it again, there we go. A bunch of test fixture things. Where did I start with? There it is. So I start a workflow off with a really simple object. It just has one field called widgets and quantities. That's a map of names to desired quantities. So that looks good. Go forth and fail. Bam, failed. So the execution ID is a unique identifier across all of the currently retained workflow executions. At SBS Commerce, we use UUIDs for this. It makes it really difficult when you're looking at this console and there are 350 executions to pick out the particular one you want, but a lot of times we don't necessarily need to find a specific one. We need to find the 3 that failed in this way, or the 3 that are still running, doing something. So it's not that bad. Although I would say that this console is one of the sort of cons of the simple workflow framework. In general, if you talk to Amazon about it, they will tell you that they don't mean this to be the console that everyone uses for everything. It's just sort of a proof of concept, or like just the bare framework that you need to kind of get stuff going. And they expect you to use SDK calls to build your own UI around things. But we don't. We just use this one. So here's a failed workflow. It also has a run ID. And you can see it's already closed because it failed. These are the events that happened. So execution was started, and there's the input data. And a decision task was scheduled, so these two go together, and that's just saying I'm scheduling something to go onto this task list, and then something picked it up off the task list and started to work with it. And then I completed that decision, and the decision that I gave back to Simple Workflow is, okay, I need you now to schedule this activity task. And I'll show you the code that does this in a minute. It's Java, so it'll be kind of ugly and lots of ceremony, but you'll be able to figure it out. And so I say go out and validate widgets by name, which is the activity that we know to define. And then it went out and talked to that RDS database, and out of the widgets that I asked for that are in this initial SQL file but aren't in the currently migrated schema, it found none of them. And so basically the business logic is, oh, you didn't find something that you were looking for, so the customer asked for stuff we don't know about. And then it schedules another decision. The decision is fail the workflow, please. And then Simple Workflow gets that and fails it. Boom, done. You can also see which activities were run and sort of in what order. And you can see here, there's the result, and that's another one of these objects. Response. So see, ideally you would want it to be, or like here's the ID, here's the name, and then these are found the ones that you wanted to find. So what does your decider code look like in this world? It's kind of ugly. In the just straight up SDK, SWF world, I'm sort of building my own run loop for things that need to pull, because the way that you do everything on both the activity and the decider side with just the raw SDK is you start up the thing and it just constantly pulls its configured task list for new work and then reacts to things as they come in. And activities just get a request, do the thing. You find them. I'll show you. So it, in its run loop, it sends Simple Workflow a pull for activity task request, which means give me an activity task from my task list, and then it gets one eventually. If it's not null, it means there's work actually to be done. If it is null, then it just sleeps for a little bit and tries again. And if it is a request for the thing that it currently knows how to do. So if you had multiple different things you wanted to do with the data store, you would have different methods in here and different, what's the activity type on the task. Okay. And then I just go out and do the thing. So, and in the decider side, things are a little bit more complicated. That's the task decider. The run loop looks a lot simpler, but what you're actually doing in the decider is you get an event that has attached to it the history of all the events. I'm sorry, you get a decision task that says make a decision about this workflow, but attached to that is a list of all the events. So right before this decision task was scheduled, I got a decision task with these first 7 events all in the list. So the way that you would generally deal with that is you build a state machine that just, so here you can see I get the decision task. If its task token is not null, then I get all of its events and I run through. I mean, I have just a bunch of states. So it just runs through the state machine with the events that it has until it gets to whatever the end is, what the most current thing is, and then you switch based on that. You know, if it's validate widgets, then I make a new decision. That is a schedule activity task. Then I say I want validate widgets by name, this version, give it an ID, and I build the message. I build the message body into a JSON string, and then I tell the Simple Workflow SDK client that I'm responding to the decision task. I'm completing it with the decision to get the widget, and this is a decisions list. So you could say do this thing and this thing and this thing, and then you would get a bunch of activity task completed events back sometime later. So that is how the code works using just the raw SDK. And with that, say hello which code, which is as a service. There's another way to write this kind of code that doesn't require you to handle the polling and the run loops and the state machine sort of building. Although if you're already doing task coordination with something like Celery or Onyx in the Clojure world, you probably have something that can be converted into a state machine that works on this list of history events pretty easily. But if you're starting from scratch, it can be kind of daunting. They also provide a thing called the Flow framework. It's an extra SDK. You don't have to use it to interact with Simple Workflow. I think of it kind of like if you've worked with Kinesis at all. You can do work with Kinesis just with raw calls to the SDK or to the REST API if you want. But if you're building something that's supposed to be taking in a bunch of data off the stream and doing something with it, you probably want to build a KCL, a Kinesis consumer library. And that is a different sort of thing. Like it has you build sort of a thing that has a loop processor in it and has a factory builder and stuff. This is kind of like that, in that the way that you write your code changes pretty significantly, and whether you like it better or worse or think it's more suited is up to you. It's only available for Java and Ruby. Honestly, I would kind of rub the Ruby off the end of that because the Ruby SDK for Flow has been lagging behind for a while now. It doesn't have some of the really cool unit testing features that Java 1 does. It did not get native support for having Lambda executions be your activities, which is available at the SDK layer for anything, any language that has native AWS SDK. You can schedule a decision task with an activity type and a Lambda function, ARN, and that Lambda function will be run with your input data, and whatever result it gives back will be in the activity task completed event that comes back to you. But you can't do that in the Ruby Flow framework, but you can in Java Flow. So instead of having to have a decider, you have a workflow, and the workflow is basically just imperative code top to bottom. What do I want to do? And then when you need to call it an activity, you make an asynchronous call. And Flow provides both a promise implementation and an executor task framework to let you do that, and some really nice annotation-based stuff where you annotate your method as asynchronous with an annotation, and then say, instead of scheduling a task for an activity to be done, you have an instance of a client class that it builds for you at compile time using AspectJ source weaving based on an interface. So you make an interface for all of your activities that declare all of their methods. And then you run this against it, and you end up with a client that can take in for any point in its method signature the thing or a promise of the thing, and returns a promise. And so then your decider code becomes just top to bottom. I get a request in, okay, I need to ask the data store for this, so I client get data store activities blah, and then you have a promise back. And when that's realized, you can use it somewhere else, but you can string a bunch of those together, and what the Flow framework will do for you is just run your decider code several times. So it'll run up to the point where it needs to get a promise. It will pause that workflow execution, schedule the activity task in the background. When the activity task comes back, it will realize the promise, run the code again. It comes up to another thing that needs to make one of these client calls. It'll do that again, go to the third time, and so forth. And it does all the stitching together of event IDs for you when you do that. So if you look at these events, right, like this one was scheduled by event 2 and started by event 3. And sometimes those get, this is really straightforward because it only took it one PostgreSQL lookup to fail, right? But sometimes sometimes you have a large number of events, but sometimes they also aren't just like right straight in order like that. So if you needed to figure out what scheduled this thing that's coming back to you in order to stitch it into something, you might have to keep track of these or reason about them in the history event list that you get. Not so with the Flow framework. You just say activity client do this thing, and then it satisfies the promise with the result of that thing whenever it comes. And I have a little bit of code that sort of shows this. It's not super working right now because IntelliJ is in this nice state where it keeps deciding that these things want to be source version 1.5, where things like annotations don't work. I set the project up wrong originally, and getting it cleaned out without deleting the whole project and restarting it is a problem. So that I wasn't able to solve before we're done. But so here you can see, like, I have a decider interface, and these are the annotations that I was talking about in the Flow framework. So this is a workflow. These are some default options for every invocation of this workflow. This is the task list it would be on. Here's where I'm declaring the version. So this is 0.1. The state machine version I showed you is registered as 0.1.0. So if I had this running and I had that one running, depending upon which version the thing that made the SDK call to start the workflow asked for, it would get either the state machine version or the Flow version. So you can have multiple versions of activities and deciders running at the same time, as long as they all know what to ask for to keep them from crossing. That's really useful for things like blue-green testing. I want to see how this works better if we use all DynamoDB for something, whatever. You can have everything be bumped one revision, but still keep the other one active. And then this doesn't do super much right now. This is the data. So this is the activity interface. Again, this has some options like that. And then this would be built out into a client if I could get the AspectJ Weaver to work in this everything is Java 1.5 world, which I can't. You would end up with a client instance of this that could take either a validate widget request or a promise validate widget request. So you'd have two overloaded methods. They would both return promise validate widget response. And in here, so I'm getting one of these from the, like where I started it in the console, or if you had a program or a Lambda function doing it. So I'm just building the list of names out of that object. And then at this point, this would be a promise. and this would be a call to a client that implements that interface that I'd be getting. And all of the stuff that I showed you about polling for stuff and switching on task type and looking through the history would be handled behind the scenes. So it's cool. I don't hate it. And there's also a JUnit task runner that lets you build out stubs for all of your activity types and run the workflow using, like you can set the workflow clock speed. So if you want to test that something times out after 3 days, you could set that unit test up to run at 3,000 times normal speed. And it doesn't actually run in AWS. So it's building out the task coordination just inside a JUnit task runner, so you don't, I mean, it's not very expensive to run a workflow, but this way your CI tests aren't also running workflows, for example. Getting the DevOps with SWF is pretty easy. It does put stuff into CloudWatch that can be useful. It's not the most useful stuff. It's hard, for example, to scale appropriately. Like if you have workers in an auto-scaling group, the CloudWatch metrics that are available to you are good for figuring out why a workflow isn't working the way you expect, not so great for making decisions about scaling up, scaling down. And I can talk more about that if anybody has questions about it. And generally just, treat it like you would any other service, right? Get your logs off the instances or out of Lambda so you can look at them. The one thing that I do not like is that CloudFormation doesn't have, I don't know if you use CloudFormation at all, it lets you describe your AWS resources in a JSON file, and then you can just run that and it stands up all the stuff. And then later you can find that stack and say, tear it down and tear all the stuff down. And I mean everything, like your RDS instance, the IAM role that lets you talk to that instance, security groups, VPCs, everything you need to stand up infrastructure. But it doesn't have support for the simple workflow things like domains and task lists. So you still have to go out and make your domain by hand. Someone with the prod keys to your company account has to go and do that, which can be a pain. Are there any questions? Yes.
I was just wondering, like, what's the magic sauce? Like, say this didn't exist. You can imagine I write a piece of code, it does something, and then puts a message in a task queue. Then another piece of code reads that message, does something, puts another message in the task queue, right? Mm-hmm. So what did jumping through all these hoops, like what did this accomplish? Like what?
I don't ever have to know whether my task queue is up. I don't have to manage it. I don't have to.
We're at SQS or something, right? So say you have a reliable task queue already. You have.
Yeah, but you're not. You're still. I mean, I make it sound like you're jumping through a lot of hoops, but you're getting a lot for free in that, you're not having to register and deregister stuff necessarily. Task lists have much better delivery semantics than SQS, for example. Like there's no visibility window. Like stuff is just available to whoever picks it up. You also get your workflow history, which has a retention period, which you could write it, right? Mm-hmm. I mean, these are all, there's nothing here that's not doable by a Turing compatible or Turing complete language, right? Like you could do exactly what you said. You could have an SQS queue, you could have workers that know how to pick stuff up off of it and then write event state out to a Kinesis stream or a DynamoDB table or whatever. But you're spending all that time writing stuff that's not your business logic. So it's just another, I guess this is kind of what I think about AWS in general, right? Like the value proposition is lock yourself into our ecosystem and we will take away infrastructure concerns from you. You run something on EC2 or on Lambda, like someone's getting a PagerDuty alert when that hard drive fails, but it's not you. This is, so yeah, there are trade-offs, right? Like, and if you have a bunch of investment already in building out a task coordination framework using something like Celery or Onyx or one of the other open source tools for building and managing this infrastructure, then maybe SWF doesn't have a lot of benefit. In the specific case of SPS Commerce, where I work, what we had a large investment into that we're endeavoring to replace is Oracle People, Business Process Execution Language, which is just tons of XML. It has to run on a certain version of OC4J. We pay them a lot We pay Oracle a lot every year because we need to run a no longer supported version of OC4J to run our people workers. It seemed like it was worth starting over. But if you are, if you have a lot of that stuff written already, then maybe you want to keep it.
So I assume you can have activities be retried if they time out?
Yes, you can have activities be retried. You can set exponential retry with backoff. You can set which particular exceptions in the Flow framework. You can say, like, these 4 exceptions should have this exponential backoff strategy. These 4 exceptions aren't retriable, or no other exceptions are retriable, and it works really well.
Your business model, all the circles and arrows and boxes and stuff, looks like looks very complicated, but I think in the real world it's an oversimplification.
Yeah, I think that's probably true. I'd add, I mean, we're not doing anything incredibly complex from a types of different things perspective at SPS Commerce, and we have 8 kinds of activity workers, 9 different sets of activities that do coordinate work with different collaborating services, and not just like the data store, but like we have one that talks to an abstracted data store service over a lot of different kinds of data stores that we have modernized a little bit, but then a lot of things that talk to on-premises services that don't have a cloud replacement yet. And we need to put this into this WSDL format and send it up to this endpoint or it doesn't work. So yeah, I think that you're right, that business processes in general are more complicated. But simple workflow is about the tooling for modeling them. So I kept it as, I wanted to make it fit on one slide. I didn't want to go to page 2 of the business process flow, so I did oversimplify it, yes. What else?
How easy is it to clone a workflow to another domain?
The workload console has you can just restart it and say this one, rerun. And you can also get all the data that started that workflow, the type and the input data right out of here. And you can do that with an SDK call too. So if you had, you could, for example, if something was dying in US East 1 and you were hitting, like none of my emails are going out or whatever, you could start failing over by throwing those those workflow start events into a Kinesis stream and have something else pick them up and restart them on another region or something. So the only other slide I have is a bunch of stuff. All the source code for this talk, including the database and all of the backend service stuff, is at the GitHub repository. Also these slides. And then the slides have links to simple workflow documentation. That's my email address. That's the image credit for that cool sewing machine picture. Thank you very much.